Good evening, everyone, and thank you for listening to the Futura Podcast, where we dive into how emerging technologies will impact the world and your bank account. I'm Trent Fowler, and joining me, as always, is my co-host, Thomas Frog. Thomas and I are futurists, keynote speakers, and consultants with decades of experience in analyzing trends and communicating new developments to audiences across the world. Reach out to us at futurapodcast.com/contact-futurati if you'd like to hire us for consulting, to speak at your event, or to advertise on our podcast. So, Thomas, we wrapped up another interview in our series exploring the philosophy of artificial intelligence, this time with John Wentworth, who is an independent AI researcher with a focus on agency and abstraction. Before we started recording, you said that might be the most abstract interview we've ever done. What stood out about it to you?
The terminology that he used was not something that I was instantly familiar with. And just kind of how he talked about things. But I understand now how it all ties into the AI world that we're trying to create. And it also kind of clues me in as to how we're really quite a long ways away from artificial general intelligence. Like, a lot of people are concerned that we're right there, right on the edge, but we're not. There's things like awareness and things like being able to purpose and motivation and control. All of those things seem to be in the works, but we're not quite there yet.
Yeah, one thing I really like about John, and one of the reasons I want to talk to him, is that he's asking what I consider to be some of the foundational questions. Like, before any of this gets off the ground, you need to have a clear idea of what an agent is, because that's what we're afraid of. We're not afraid of a super advanced language model that confuses people or tricks people. I mean, that is a danger, but it's really more when we have something smarter than we are acting in the world, that could have deleterious consequences if it doesn't want the same things we want. So he's asking himself really basic questions about what agency is and what are the primary tools a mind like that would use to understand, manipulate, and act in the world. And so his work tends to focus on agency and abstraction. And so for that reason, it was a very abstract conversation. It's hard to talk about abstractions without being pretty abstract, I'm afraid, as is implied by the name.
Absolutely.
Yeah, so we thought it was very abstract, but very worthwhile. Hopefully you do as well. So without further ado, this is our interview with John Wentworth. Tonight, we're joined by John Wentworth. After a long career as a software engineer and data scientist, John became an independent researcher in artificial intelligence. Today, he focuses on a diverse array of topics, such as the nature of abstraction and what the word agency even means. If you enjoyed this interview, please subscribe to the podcast and share it with your friends. And don't forget to check out our website, futurapodcast.com. John, thanks so much for coming on the show.
For having me.
Absolutely. Let's hear a little bit about your background, your interest, and what brought you to working on the problems that you were working on today.
Okay. So background-wise, I was a data scientist, bounced around startups for like 5 years or so. Got tired of that, wanted to move into doing something more researchy. Interacted with Miri a bit, and ended up doing fairly blue sky style research on an agency. And in particular, my main focus is on abstraction. So the sort of prototypical question that I think about is, you've got, say, this notebook. What makes this notebook sort of a natural object to think about as an object, right? Like sort of the left half of this notebook or the right half of this notebook, or if we'd like number all the atoms in here, take all the even numbered atoms. Those all seem like sort of less natural objects to think about. It would be more surprising if we find other kinds of minds like aliens or AIs thinking about left half of the notebook and right half of the notebook. Whereas we sort of intuitively expect it's more likely that other kinds of minds will just like think of this as a notebook. So my research is mostly about what can we say about that, both mathematically and empirically, like what are the sort of stories by which agents, different kinds of agents, would converge on using similar concepts.
Okay, well, I plan on spending almost the entire conversation talking about abstraction and agency, but first I thought we could maybe get a little bit more into the mechanics of what it means to be an independent researcher. I imagine quite a lot of people listening to this will be fascinated by that whole career track and like what your days look like, how you set research agendas, how do you get paid. You discussed a lot of this on Less Wrong, but just for the record, if you could spend a few minutes walking through that.
Sure. So let's start with the how you get paid, because for anyone interested in independent research, that's certainly the big question. I get paid by grants. Specifically, my last few have been from the Long-Term Future Fund. This is very much the sort of thing that they historically funded, research relevant to AI alignment and safety ultimately. Although they're undergoing they're sort of morphing into something slightly different now, so we have yet to see how that's going to shake out. But generally, that's where the money comes from right now. Day to day, this has actually changed significantly in the past year. Previously, most of my day was just like at a notebook or writing code or whatever. Originally, just working out of the living room. Later on, I worked out of an office in Berkeley with some other people doing AI relevant research, alignment research specifically. In the past year, I've started working with David Laurel on a day-to-day basis. Work in this office here, see all of our ongoing things scattered over the whiteboards. Mostly what it looks like depends on what we're doing. If we're in something more theoretical, we'll mostly be at the whiteboard all day. If we're coding, like last month or two, we've mostly been coding, so at our computers writing code all day.
So what do deliverables look like to you?
Good question. Most of my deliverables to date have been in the form of blog posts going through like whatever math we've been working on. In the future, I expect at least some of our deliverables will look more like products. But that's like we're trying to get our way across the theory practice gap, and we're still on the theory side of it for now.
Interesting. So what products would an independent AI safety researcher put out? I mean, other than a solution to the alignment problem, what would a product look? How do you product?
Yeah, good question. So one we've been playing around with lately has been, well, if you have a good understanding of abstraction, then a conceptually simple product that you should be able to build is an image editor, right? Like, say you take your AI image generator and it generates an image for you. You should be able to click on a tree in the image and then drag it around as a tree, right? So sort of like Photoshop does, except Photoshop does this badly, right? Like Photoshop sort of just cuts out all these pixels and then you drag the pixels around. What you'd really like to be able to do is edit the image in a way that's sort of editing in concept space, so that you move this tree around and the whole image just updates as though there's now a tree over here instead of over there, right? So interesting. Shadows would follow it, or the tree would just adjust to look more like a tree would if it were growing over here, that sort of thing. And to be clear, we can't do that yet, but that's a example of an application that sort of we have in mind to drive our research as an intermediate step to more complicated things.
And then how do you pick the problems that you work on? So I've read through a lot of your sequences. You've evolved a fair bit over the years. You did aging stuff for a while, and abstraction has been a dominant leitmotif. So what steers the direction of your thought?
So early on, it was I have a background in a lot of different areas. I've done some biology research during my undergrad. I've done obviously AI stuff. On the side, I was spent a fair bit of time and effort studying economics. And a thing I saw a lot was different fields sort of looking like they're blocked on similar problems. So classic example of this is in AI, we have interpretability work taken off these days, right? Mm-hmm. But biology has basically a similar problem to it. You've got these sort of low-level biochemical circuits with like, tens of thousands of molecules interacting in them. And there's a problem of like, okay, how do we interpret what these circuits are doing or what they mean, right? Like that's systems biology in a nutshell. And that's like if you look at the problems that I think they're bottlenecked on, I think a lot of it boils down to you can look at these internal circuits and sort of see that maybe they're doing something that can be described by a simpler circuit, but that still doesn't really talk about how they relate to the outside. And that's sort of the big piece that we don't have for interpretability biology or AI right now, is like intuitively we think these internal parts are representing something in the outside world, but in order to talk about that mathematically, we need to have some characterization of like, what are these sorts of things in the outside world that can be represented? And like, what does that even mean? What's the actual relationship between those things? So yeah, that was an example of like these sort of paths, one of the paths that leads to studying abstraction.
So do you spend a lot of time thinking about what if scenarios? This doesn't currently exist, and if it did exist, how would it work, and how would that change things?
Very little time on that sort of thing. The vast majority of my time is on like thinking about things which do already exist and sort of trying to better understand them.
There's enough existing stuff to figure out, Thomas, without worrying about stuff that doesn't exist.
Well, yeah. I was just thinking, well, if an oak tree actually was able to use a smartphone and able to call the birch tree over here, what would they say to each other? And okay, we're going down a different path there. Sorry.
It's classic Futura Podcast curveballs. Yeah, there's classic curveballs. All right.
Hello, this is Trent Fowler, co-host of the Futura Podcast. One of the most common pieces of marketing advice I've come across is to know your audience and give them what they want. One difficulty in podcasting is that it's actually pretty hard to do this. None of the major platforms give us any way to reach out to you, our listeners, to find out what you enjoy about the Futura Podcast and what you'd like to see done differently. So we've decided to record this commercial and ask you directly to reach out to us. Head over to futuratipodcast.com, go to the contact page, and drop us a line. Tell us about your favorite and least favorite episodes, what you'd like to see us cover in the future, and anything else you want us to know. We produce this show for you, and we want your advice so we can make it even better. Thank you.
I wanted to focus on abstraction and agency, and I was kind of kicking around the ordering, and I could see a case being made for starting with either one. So why don't you start with the one you think is more fundamental, and that can, on its own, contain some interesting information.
Cool. Okay, I think either one of these can be considered fundamental, so I'm going to try to give like a short pitch of how you would take either one to be fundamental. Mm-hmm. So if you're coming at it from a sort of philosophical angle, in some sense, all abstraction has to happen in a mind, right? Like the universe, just like there's a bunch of quantum fields, there's no sort of inherent abstraction out there in the world. Insofar as natural abstractions, like abstractions that are natural for a particular environment, make sense to talk about, it's because different kinds of agents will tend to converge on similar abstractions. And we can talk later about like why that would happen, but that's sort of that's from a philosophical angle, that's sort of the foundational reason that like abstractions can be a thing at all. So from that angle, it sort of makes sense to try to understand agency to some degree first. All right. Other side, making abstraction is more fundamental. If you're thinking about agency, agents themselves are these like fairly abstract things, right? Like you or I, made of atoms and whatnot, but like pretty much all the stuff we want to say when talking about things as agents, like talking about having world models or beliefs or goals or plans or any of that stuff, that's all at a very high level of abstraction. So if we want to be able to talk about those agents in a way that's not just sort of assuming away their relationship to the stuff they're made of, then you kind of necessarily have to be talking about abstraction there. Agents are abstract things.
Yeah. Yeah, that's kind of the same dilemma I confront. It's like, well, your theory of abstraction will redound upon how you define an agent in the first place, but abstractions happen for agents. So maybe it would be better just to start with agents then. I mean, it sounds to me of the two, that might be the more fundamental in this context. So, I mean, how do you think paradigmatically about agents? Do you have a concise definition of what one is that we could use to determine whether or not ChatGPT qualified or GPT-4 qualified?
So first things first, I don't usually try to like have a precise definition of an agent in mind. That's not a thing that I necessarily need. What I want is to be building theory that'll be like that'll like robustly apply to whatever notions of agency end up making sense. So like we have some clear examples of agents in the world around us, notably humans, various animals to some extent, depending on like sort of levels of agency we're talking about, various AIs to some extent, depending on what levels of agency we're talking about. I keep these sorts of examples in mind when like, working at the whiteboard and developing theories and whatnot. And like, I want to make sure that theory will apply to like as many of these different kinds of agents as possible. And then as long as it's robust to like reasonable distribution of agents, I expect that later on, once we have more precise notions of what agency is, the theory will generalize to those.
Interesting. Okay, so the examples of agents we have are humans paradigmatically. What is it that makes a human an agent? Like maybe we'll just help to go through some ostensive definition or examples rather of it. So it's, just go ahead.
Sure. So there's a few what you might call levels of agency that I keep in mind here. The sort of lowest level would be something that's choosing actions, those are, as a function of observations, whatever those are, in order to make certain things happen in the world that wouldn't normally happen. This is a very broad definition. By this definition, a thermostat counts as an agent. So that I would call that sort of maybe the most basic or sort of lowest level notion of what you might consider an agent. A step up from there, you've got something that has an internal world model. So something that's explicitly representing some stuff externally, whatever that means. And typically that'll come along with some sort of planning going on internally. A step up from there, you've got things like a self model. So for instance, being able to pass the mirror test. Animals, like lower level things like a thermostat or bacteria won't do that, but some animals do. So we're still not all the way up to like humans yet. Where humans start to look significantly different is when you combine all of that with language capabilities and probably some other things that we haven't put our finger on yet. I don't think we've really properly characterized all the criteria that make humans properly agentic. But I guess like the sort of meta thing that I'm trying to convey here is that there are multiple levels of agency which involve different things, and different people talk about different levels of that as agents, and like they all make sense to talk about. You just have to sort of be clear which one you're working with at any given time.
So it's mostly adding faculties.
Roughly speaking, yeah.
Okay, and do you have any thoughts on how like agency is different from teleology? Because it occurs to me that like plants are teleological. They are kind of going towards something, and there's a very rudimentary, probably invalid sense in which they execute actions. I mean, I'm thinking phototropism, although it's purely mechanistic, but then you've got an agent like a human being where it seems like obviously something much more sophisticated is happening. And I've sort of struggled to disambiguate those things and move kind of between them in my own thinking. And I thought maybe you might have a better dividing line.
Yeah. So on teleology specifically, one major dividing line is between systems that have been optimized to do something. So for instance, anything that evolved, or like any evolved organisms, are optimized for, reproducing and propagation, growing in whatever environment. But that doesn't mean that they are doing optimization themselves. So like, for instance, a human internally we make plans, right? That's sort of doing optimization in our heads to like find a good plan instead of a bad plan. So there's a difference between like this thing has been optimized versus it's doing some, actually I skipped the middle one, versus thing we skipped versus it's doing some like planning style thing in its head. And each of those gives you sort of a different notion of teleology. I think in the philosophy literature these days, the most common notion of teleology is going to be grounded in like has been optimized for something. So they're going to be trying to ground in evolution style stuff. But you could just as easily try to ground teleology in one of these other levels of faculties.
Yeah, that's because the optimization I don't love. I mean, I know what they're getting at, but it seems like there's a more basic fact, and that's like it's oriented towards something, which obviously interfaces with the idea of evolution, like it's oriented towards propagation. But I don't think the optimization part necessarily adds anything. Although, I mean, I haven't read those papers, so yeah, I could be wrong.
Yeah. So I earlier mentioned that like with abstraction, for instance, abstraction sort of fundamentally has to ground out in minds because, you know, it's minds that are doing the abstraction. But it does feel like that if you're just saying, well, lots of minds will converge on similar abstractions, that's not really getting at the thing that's fundamentally going on. Like you're sort of saying that these things will converge, and that's like how it's ultimately grounded out. But the really interesting question then is like, what's going on in the environment that makes them all converge on something? There's a similar thing with teleology. With teleology, if you're thinking about like, well, how do we ground this out fundamentally? Then I think this like optimization story is probably a sufficient way to ground it out, but it's not really getting at like why it's happening. Like, what are the properties of the system that are like making this teleology thing go on?
Well, I think ultimately it's that it's alive. That's probably the basic distinction there. And part of what a living thing is doing is trying to continue, right?
Yeah, this one I don't really buy. So for instance, if I look at here, one moment. So here I have an audio cable, right? Has this like funny shaped tip on it. And on my computer, I have an audio cord, audio port currently occupied by a different audio cable. And if I'm looking at this audio cable and that audio port, I'm like, man, this is an awfully specific shape that fits directly into that awfully specific shape. Well, that's an interesting coincidence. That like, I look at that and I'm like, man, that sure suggests some sort of teleology there. Like, you don't usually just like happen to get these very specific shapes that fit into another very specific shape, unless this system is like be optimized for something or evolving or something along those lines. Which like we can ground out teleology in terms of being optimized for something or in terms of reproducing or whatever, but that's still, like I was saying, there's still a question of like, I'm looking at this cord, I'm looking at this port. When I'm thinking like, man, there's some teleology going on here, my thoughts here aren't routing through like, this must have evolved, or this must have this must have been optimized for something. There's some sort of pattern here that it feels like I'm recognizing that's like, I can ground it out in terms of having been optimized or having evolved, but there's a more specific pattern than that.
Are you enjoying this episode of the Futura Podcast? If so, please like it, give the show a 5-star rating on Apple Podcast, Spotify, or wherever you get your podcasts, and share it with your friends. By far, the best way to help us grow is to spread the word on social media, which will expose our content to more people and help us continue to bring you interviews with world-leading experts in AI, quantum computing, cryptocurrencies, and so much more. Thank you in advance.
So I guess you're using a wider notion of teleology than I am. Like, I would say the teleology is in your mind as the perceiver and in the mind of the person who made it. I don't know that I would say that Jack is teleological exactly. Like, it's built for a purpose, but don't know that that's the same thing. I'd have to think about that.
That is very low. Yeah.
Okay. All right. Well, we don't have to spend all day debating that. Now talk to me a little bit about abstraction.
Okay. That was a broad question. Okay. So with some angles through which I usually think about abstraction. One starting point is if I think about the number of functions from a 1 megabyte image to a yes/no answer to the question, does this image contain a water bottle? This one. The number of functions from image to water bottle is something like 2 to the 2 to the million. Actually, bytes. So I guess 2 to the 2 to the 8 million. Point is, if you are trying to learn what a water bottle is from like looking at a bunch of images that are labeled yes, no, water bottle, or no, learning that via brute force from just a bunch of data would take this like ridiculous exponentially large number of examples. In practice, human babies take like, or infants, I guess, take like 2, 3 examples, sometimes 1.
Yeah.
So what this tells us is whatever's going on with like different humans being able to communicate at all, different humans being able to take a word and like convey roughly what they're trying to point to via a word at all. The fact that that works implies that we're not just doing like some brute force learning of what the word means from data. In some sense, almost all of the work of like attaching words to things they mean has to be in a sort of undirected step where we're just like looking at the world and noticing patterns in it and finding stuff that like this water bottle that's sort of a natural candidate to attach a word to. And by the time we come along and like actually attach the word to, you know, category of thing in the world, we have to have already done most of the work of like figuring out what the candidates are. So earlier I used the example of like left half of notebook versus right half of notebook. Like approximately all of the work of figuring out that this notebook is a natural object has to be done in a way that's not routing through just like getting a bunch of labeled examples. It has to be like they're recognizing some sort of patterns. All right, so that's like piece 1. We know that there, just because language works at all, there has to be some sort of patterns in the environment that lots of different humans are recognizing in roughly the same way. What the heck are those? Piece 2. This is a sort of more specific hypothesis for what those sorts of patterns are. The guess is that in our world, there are usually relatively low dimensional interactions between things that aren't too close together. Prototypical example of this from physics would be you've got some gas, you let it sit there for a minute, and you ask, okay, if I have like some information about the sort of low-level state of this gas at the initial time, what does that tell me about the low-level state of the gas at the final time? And the neat thing about an ideal gas is its dynamics are chaotic, so almost all of the information will be wiped out.
Yeah.
If you have like any initial uncertainty at all, you let it sit for a minute, then at the end, you're just going to have no idea about any of the characteristics of that gas, except for a few things which are conserved, like energy, volume, particle density, these things that aren't changing as the gas moves. So this is a sort of prototypical example where you've got this sort of information bottleneck, right? You've got this very low dimensional set of summary statistics that summarize everything about the gas at the initial time that's relevant to the gas at the later time. And the guess, the hypothesis, is that this is sort of the prototypical case for most stuff in our world most of the time. Like if I am wondering about how much water is left in my water bottle and whether I need to refill it, I can go walk out the door and look at how the clouds are moving in the sky. I can look at how long it's been since the grass is cut. I can look at the color of my neighbor's house, and none of these things will tell me anything whatsoever about how much water is left in my water. There's just like most there just isn't that much informational interaction between most stuff most of the time.
Yeah.
And if that's true, then the like sort of natural guess from that is that those low dimensional summaries are natural things for agents to be using as concepts. Like agents are naturally going to converge on tracking those low dimensional summaries because like that's the stuff that's usually going to be relevant to other stuff. So those are sort of the natural candidates for convergent or natural abstractions.
So it sounds like this would rely on a theory of concept formation, because I mean, to begin with, you need to understand what it is that human infants are seeing in the world and how they're building up concepts from presumably perceptual data. I mean, either you think that's what they're doing, you think they're inbuilt with concepts, or, you know, there's a platonic form of concepts out there and they're somehow interacting with that. Like there's a limited number of theories that you can endorse for how it is that we arrive at concepts in the first place. So just curious, like it's a very long-standing problem in philosophy, and I'm sort of curious as to whether or not you've found a theory that you like.
Yeah. So the way so that the problem of like building cognitive models of how any particular agent actually does this is like one of maybe 2 or 3 major pieces of what a full theory would consist. So a full theory, you'd have first a characterization of like what these patterns are in the environment. So like in some environment with some relatively general structure to it, like space-time being a thing, for instance, what sorts of low dimensional, or can you characterize what sorts of low dimensional summaries you'll have between stuff? That's one piece. A second piece then is how do actual agents with realistic architectures converge to using those things, or how do they end up representing them internally? That's where learning, both for neural nets and for babies, for other biological systems, that's where all that would be relevant. And that's actually beyond what we're doing right now. We don't even try to tackle that part of it yet. We're still just on the like, how do we characterize this in the environment part? But like the place where I'd ultimately like this to go over the next few years is like decent characterization of what the patterns are in the environment. Combine that with like fairly general theories coming out of interpretability. In particular, I think singular learning theory is promising in this department. And then ideally stick those two things together. So you'd be like, all right, here's this theory that's talking about what sorts of structures show up in neural nets. Hopefully we can also generalize that to talk in some way about other kinds of minds, humans, animals, or whatever. Here's a theory that's characterizing these sort of natural patterns in the environment. Now let's get some theorems that say like, okay, representations internal to these minds are going to converge under selection or whatever to representing these sorts of patterns in the environment specifically.
Well, so what are your thoughts on those patterns in the environment? Because I have some theories, but I'm curious to know how you're thinking about just characterizing those. I mean, first of all, you notice regularities, right? But it has to go further than that, or else you wouldn't even be able to form concepts at all. So what do you think is going on as an infant looks around and notices that some things are solid, some things are not, like some things move, some things don't. Like I noticed that my son, when he was probably 3.5, this would have been 8 months ago, he did this series of experiments where he went around pouring things on different things. Like he would pour water on rocks and on grass and on wet dirt and on the hardwood and on the carpet. He did it with orange juice. He did it with yogurt, and he just did this like for 3 weeks. He just went around pouring on stuff, and you could just feel the little model building in his mind. So there's definitely something happening there, and it's teleological too, if that matters to anyone. But what do you think is going on? Like, how does that process get off the ground? What does the infant notice at first?
All right, I'm going to start by like talking about this in the concept in terms of like a scientist doing an experiment, because I think it's a little more legible there, and then we'll try to tie it back to the infant. So if you got a scientist doing an experiment, you've got your like bullshit middle school story. Oh, are we allowed to swear here?
Yeah, go for it.
Okay.
Fuck it.
So you've got your bullshit middle school story about like, you're gonna get a hypothesis, test it, blah blah blah. It's kind of crap. Like the big thing that I would say a scientist is looking for is reproducibility, right? They want an experiment where like you can do this experiment over and over again, get reproducible results. And what that implies is you can do this experiment in like different labs, in different places, being done by different people on different days. The weather's going to be different. There's going to be like, sometimes the floor is swept, sometimes the floor isn't swept. So what reproducibility implies is that whatever things you're controlling, those handful of things that you're controlling, because you can't control billions of things, you can't control moles of things, you can only control a few variables realistically. Whatever those few variables are, were enough to mediate between whatever's going on in this experiment and whatever's going on in the rest of the world.
Mm-hmm.
So we talked before about like these low dimensional summaries between stuff, right? That's what's going on with reproducibility in science, is you're finding a low dimensional summary that's going to mediate between whatever's going on in the experiment and whatever's going on in the rest of the world. My guess is that a similar thing is going on with infants, or toddlers, or like kids learning, right? Like they're trying out a lot of stuff. The thing that they're looking for at a lowish level is something like reproducibility or mediation. Like they're looking for, whatever is going on around, I still see like the same things happening when I do X, or like whatever's going on around me, I just need to know like X or Y, and then I will know what happens when I do this. That's where these sort of low dimensional summaries would come in for them.
So why is it now that this is such a important topic that your research is getting funded? Would this type of research have gotten funded 10 years ago or 20 years ago?
So first of all, notice that I am being funded by the Long-Term Future Fund, which is like this weird rationalist / EA fund specifically for AI alignment. Some of the research I'm doing is a sort of thing that would be funded in academia, but like it would be funded as like, this is some cool math, not as like there's any particular application that you necessarily have in mind in that context. In the case of like the LTFF, they're funding me because they expect this to be relevant to AI alignment. Because like we can get into why that is later if you want to ask about that.
Oh, we will. Actually, right. How would your work on agency and alignment factor into, well, two things. So one is AI safety. I presume, given that you blog on Less Wrong all the time, you buy the basic Yudkowskian arguments that this is a real danger and that alignment is at least a solvable problem, or you would advocate for a total shutdown. So why don't we start with safety? What does this work have to do with safety? I think in the case of agency, it's relatively easy to tell, but abstraction might be worthwhile as well. And then is there anything coming out of your work that is relevant to the alignment question as such? Or, maybe that's a separate problem that you solve once you figured out what an agent is.
Yep. Yeah. So the thing that I think of as the sort of most prototypical way that abstraction is sort of a necessary element for understanding alignment is the pointer problem.
The pointer problem?
Pointer problem, yes.
Okay.
The idea is humans, if you ask like, what are the inputs to human values or human utility function, insofar as that's a thing? Like what sorts of things do we value? What are our utilities over? And kind of obvious part of the answer is, well, I don't care about quantum fields per se. I care about high level abstract things like water bottles and cars and trees and all that jazz, right? So when it comes time to align AI, if this AI just has totally different concepts from a human, if it's not thinking about the world in terms of water bottles and trees and cars and stuff, then it's going to be hella difficult to get this thing to do what I want, because what I want is in terms of concepts that it doesn't even have. Like if I'm trying to get my AI to just like give me a glass of water, or put two identical strawberries on a plate, your example,
Right.
and it just doesn't have the concept of strawberries. If it's thinking about things that are just like kind of orthogonal strawberries, then in order to get it to do what I want, I need like a pretty like large specification of what the heck it is I want. I'm going to spell out like lots of tiny little details, what the heck I'm even talking about when I say strawberry, right? On the other hand, if it has concepts that are basically isomorphic to ours, if it has a concept of strawberry that basically matches our concept of strawberry, then it's just a matter of like fiddling a pointer in this thing's goal function, right? Like it has the concept of strawberries. You just need to like point to that concept, find the right concept, point to it, and be like, okay, optimize that thing. You know what it is. Go get that. And this is, so like the reason it's called the pointers problem is that like the things we want involve pointers to concepts that live in our heads. So in order to like practically align things to those concepts, you sort of need to get a pointer in that AI's head, which is isomorphic in some way or corresponds in some way to the thing in our heads.
Do you think you could have a superintelligence that for which there was no overlap in the conceptual structure? And I don't mean normative concepts, but it's hard for me to even understand what a superintelligence would be that didn't understand what a strawberry was.
Sure. So the classic idealized example of this, not necessarily practical to build, but idealized example would be, suppose you've got a mind that just does full quantum level, low level simulation of the universe, has some utility function that's just straight up specified in terms of those quantum fields, and then brute force maximizes expected utility under like that model, that utility function. Obviously, this thing would not be at all plausible to build in our world. Your Jupyter brain will not have enough compute for that. But if you had infinite compute, then like in principle, that's a thing you could build. And that thing doesn't really have the concept of a strawberry in the same sense that physics itself doesn't have the concept of a strawberry. Like it's sort of arguably embedded in there in some sense, but it's not really factoring its internal cognition through that concept.
But in what sense is such a thing as superintelligence? It's certainly not an agent, because I just don't know how you could be an agent without interacting with the world enough to notice that there are these statistical regularities and at least attempt to arrive at a compressed representation of it and tag it with a word. I don't even know what an agent would be if it doesn't have something kind of like that.
So this thing could still do a lot of prototypical agentic things, right? Like can still be like taking actions in the world. It can still have this utility function over like low level state of the universe. Therefore, things like instrumental convergence are still going to apply. You'd still expect this thing to like build the von Neumann probes and go take over the universe, because like if it has a utility function that's over most of the universe, do that in order to maximize that utility function, right? So it has all the sort of standard properties that feed into these like arguments about AI risk and sort of standard properties that feed into arguments about agents. It's just its internal cognition is obstructed.
Well, then how does it build the von Neumann probes? Like, how does it do that without understanding electromagnetics and understanding, real strength? It just brute force searches von Neumann probes?
Yeah, that's why I said, like, this is a thing you can't actually build.
I don't feel as though you're...
But if you have infinite compute, you can just do a brute force search for, like, what things can like, my actions output that will result in, optimizing stuff far away in the universe.
I am skeptical of the feasibility of this design, sir.
Oh, it's super infeasible. Absolutely.
Okay.
It's meant more as like a conceptual, it's a conceptual tool for like what could, in some sense, different minds look like. But like, obviously, I expect minds in our worlds to not look like that. I expect them to have concepts similar to humans. That's like kind of the point of natural abstraction.
Yeah. Okay.
But-
All right.
So yesterday we got into this discussion about if AI had access to a bank account with $1 million into it, how does it know how to take action? How does it know that there's value there? What are the impulses that are necessary for it to actually make it useful? This seems to be one of the things that's lacking right now, is that there's this general understanding that because AI is good at a few things, it's good at everything. Can you expand on that a little bit?
All right. So first I have to ask, what level of AI are we talking about here? Are we talking about super intelligences? Are we talking about large language models? Are we talking about something humanish?
Do you need a dynamic and knowledgeable speaker for an event? Thomas Fry and me, Trent Fowler, are both seasoned keynote speakers, able to converse on a wide array of topics to audiences of all sizes and skill levels. Go to the contact page at futurapodcast.com to book Thomas or myself today, and let us apply our years of experience in public speaking to make your event a smashing success.
Well, okay. At what point does AI get smart enough so it knows something about it? How many years down the road do we have to go before AI is intelligent enough to know that money sitting in a bank account is worth something, and then being able to make decisions on how to use it and what it's useful for, that sort of thing?
All right. Multiple complicated issues here. So first, in some pretty permissive sense, large language models can already do this. Like if you give a prompt to your large language model that's like, hey, there's this much money sitting in my bank account, what can I do with it? It will output some text whose like meaning makes sense as things to do with money in your bank account. However, that is a lot of the work there is being done by like reading meaning into the text that's going in and the text that's going out.
Right.
So one step more advanced than that would be you've got an AI which sort of can do the reading meaning into it itself, right? Something like, I would say the main things you need for that is to have a world model that is sort of factored in terms of abstract concepts like money and bank account, things you can do with it. And then it can look at the amount of money in the bank account via whatever sensors it has and like update its model accordingly. Yeah, what to do with that, yada, yada. Some people will argue that LLMs already have that internally. I'm kind of agnostic on that one, leaning towards no. But like that would be a hard thing to tell externally because it's fundamentally talking about the internal cognition of this thing. Yeah, I think that's the main answer.
So we're probably a ways off. Like, I mean, you intimated that you don't think these large language models have internal concepts. I agree. And I do also, yeah, it's maybe a proto concept. I mean, I'm given to understand that, there are neurons that light up in the presence of, like if you have invariance in the inputs, there are neurons that consistently light up. Like anytime you use the word red, there's like a characteristic activation pattern. Something like that's probably happened neuronally as well. But I just don't know of any evidence personally, any papers I've read, that there's actually concepts in there, anything we would recognize as being like a human concept.
Well, you got to be careful there because, like, I agree there's not really evidence of that in the literature, but I would say that less reflects, like, lack of those sorts of concepts in the net and more reflects, even if they were in there, don't really know how to measure them. Like, I'm sure there are some papers that like have made up some bullshit proxy for whether this net has concepts and found either a yes or no answer. And like, this just doesn't tell us anything because we just don't really understand what it means. Well, there's sort of a rough intuitive sense of what it means, but we don't understand what it means in a way where like we can go check.
Yeah, we go look at it, say, yeah, this amounts to a concept. Well, and to be fair, I don't think we can do anything like that for the human brain either. Like we have answers about what concepts are, but it's always like when you take inputs, you notice these irregularities. There's this like process, measurement emission, context emission, whatever theory you subscribe to. That's how you arrive at concepts, and then that's sort of where the analysis takes off. But I could look at a brain scan and say, oh yes, it's the grandmother concept, it's the Jennifer Aniston concept, or whatever. Like that's what's being activated. You know, I mean, there are periodically attempts to get something like that through, but they don't last very long. It either doesn't replicate or just doesn't tell us anything particularly useful. Have you said everything you wanted to say about the connection between abstraction, natural abstractions, and safety? Because I know we sort of took some tangents.
I mean, I guess the one other thing I'd highlight is I gave like one sort of prototypical story of how it's relevant. But like that's not the only story here. Abstraction is like a pretty convergent bottleneck to a lot of different technical paths to save AI or to align AI, and it comes out in lots of other ways as well. Like if you want to do basically anything where you're like probing the internals of your AI in order to figure out whether it's doing some thing where the thing we're interested in is like some abstract thing having to do with the external world, like deception, for instance. Classic example, lots of people are interested. If you want to go probe the internals of your AI, figure out whether it's thinking deceptively or acting deceptively or whatever, then like abstraction, pretty core problem there, right? Just like this thing with concepts, it's the same issue as with concepts. You know, we have no idea how to go in there and probe it, and it's for basically the same reasons.
So, I mean, I think I know the answer to this question, but you don't think human values would be natural abstractions? Like we would expect alien minds, aliens or AIs to understand what a tree is, because it's just it's an important feature of the environment. And if you're going through the abstraction process, you're going to stumble upon trees and you'll have a word for them. Like, but something such as justice or honesty, I mean, even assuming humans have consistent concepts around those, would not be something that an AI would necessarily converge upon. Because if they did, I think we have a lot less to worry about, right?
So I'm pretty agnostic on this one. You probably are tracking this distinction, but I should say it out loud. There's an important distinction here between whether an AI has the internal concept of like justice or whatever, and whether it cares about that. On the whether it cares about that side of the story, I'm like, yeah, no, absolutely not. On the will it have the concept side, I'm much more agnostic. Like there's a lot of pieces of human values, probably some of them are natural and some aren't as concepts. And I'm just not really sure to what extent what parts of it end up being concepts that lots of minds will use.
So is there a way to use the natural abstractions work to get it to converge on and care about something like honesty or not harming people, or maybe not? Maybe it's just like step one of 200 steps to even get there in the first place. But it seems like
so the most common story I give here is what I call retargeting the search. Basic idea is by the time you have powerful AI, it's probably going to be doing some sort of internal search or planning explicitly. And this is going to have to be fairly general purpose search or planning, because that's the point of artificial general intelligence. It's the general part. So if you have that, then if you have really good interpretability tools, or like you have a good understanding of how this stuff inside the mind maps the stuff out in the environment, you should be able to go into this thing's internal search process and be like, okay, optimize for this thing over here, right? Like make some small local edits. They'll be like, here's the thing we're optimizing for. It'll go do that. And then your big problem is to like go through whatever concepts are inside of this mind and find something that you actually want to point it at. So like if honesty ends up being a natural concept, then point it at that, right? If something like do what I mean ends up being a natural concept, corrigibility, human values, just like all human values end up being a natural concept. Those are all things that you could potentially point it at. And there's this largely empirical problem of like, okay, which things will show up in there? And then like, which ones do we want to point it at?
Boy, that sure would be a stroke of luck if human values writ large are natural abstractions.
I'm maybe not quite that optimistic.
Well, I know one thing you've written a lot on is very granular critiques of different alignment and safety proposals. I was curious if any of them struck you as especially promising. If there's, if you pivoted today to focusing wholesale on alignment, which one would you double down on, or would you just start over from scratch?
Yeah. So the quote unquote obvious basic thing is, if you are simulating or emulating humans, you're probably not going to do any worse than those humans would have done anyway. So the standard baseline thing that you should be doing with something like a very powerful LLM is just prompt the thing to produce some damn alignment research, right? Note that you should not be RLHFing it. That will make the safety story worse. Just a pure predictive model that is just trying to emulate humans, prompted to try to generate some alignment research. And the harder you have to, the more optimization pressure you have to apply to it. So the more bizarre your prompt has to be, or the more you tune it or whatever, the worse the safety story gets. Aside from that, I think there's just not a lot of good options. After that, you sort of have to go understand the hard problems of abstraction and a fair bit of agency before you can really have much hope of doing better than that by a technical route.
But so you just ask the AIs to help you with your alignment homework?
Not quite. It's importantly different from that. If you take an RLHDEF model and ask it to help you, then it's going to be it has been optimized to give outputs that will be rated well, which is very different from emulating humans. You want it to be emulating humans. So you take a thing that's been optimized to predict next token in text that was actually written by humans, and you just prompt that thing with something that sounds like the beginning of a useful paper around alignment or something.
Interesting. Okay. But then otherwise we have to line out this other stuff. We would the machinery needs to be updated. Okay. Yeah. So and I think that's probably right. Yeah. I think you're probably right.
It occurs to me that there's this awareness piece that AI is not currently aware of what's around it. Mm-hmm. Just if you ask AI where your car is right now, it won't know where your car is.
Yep.
If AI needs power to survive, and I keep going back to this bank account thing, and it's sitting next to a bank account with $1 million in it. It doesn't know enough to be able to tap into that bank account and pay the
these LLMs,
pay the power bill. It seems like this awareness thing is kind of a missing piece of the equation here. Is that correct?
Missing for what is the key is important here.
Okay.
For AGI, absolutely. That doesn't necessarily mean that it's going to be the hard piece, the bottlenecking piece. It could be that you come up with some relatively simple scaffolding you can put around an LLM, and the LLM still does most of the work, and you can just get something that's basically aware. Maybe it turns out that for GPT-7, we could just feed in raw bits from a webcam and a servo motor or something, and dump that in the context window, and it will figure out the rest from there and basically end up being the way that we currently do this is mostly humans reading meaning into the text that goes in or comes out, right? It's not really clear how hard a bottleneck that's going to be, but it's definitely a piece that you need to figure out before you're going to have an AGI.
Way fascinating. Well, you give us a lot to think about, John. Do you want to point the audience at any resources? Is there any final thoughts you want to leave us with?
There's my writing on Lestron. There's a lot of it. If you want to read more about all this stuff, lots and lots of writing on Lestron.
You've got 6 sequences, I think. That's quite a lot.
Oh, that's not even the majority of it.
Is it not?
Yeah, most of it's not in the sequence. It's just random blog posts.
I got you. Okay. Well, very good. You don't have a website, or you Less Wrong is your blogging platform.
It's right out there.
Okay, excellent. Well, I presume everybody will be familiar with this, but it's lesswrong.com. If you're not, check it out. A lot of great stuff. John, among other people, are doing groundbreaking work there. So thanks so much for your time. This has been a fascinating conversation. We really appreciate it.
Cool. All right, see it.